Welcome to another episode of Setting Up Azure Resources. I'm your host, Richard Knuckles. When we left off last time, we had gone through setting up a Data Lake Analytics service and running your first set of jobs. I'd gone over my approach and my framework for setting up a job in the U-SQL script language, which includes a extractor, setting up a row set, writing the files using an outputter, and defining the files to read in using a wildcard variable. In today's video, we're going to be looking at the U-SQL Catalog. The U-SQL Catalog is a metadata framework and storage system within Data Lake Analytics that allows you to precompile data files and precompile and store U-SQL scripts for reuse in subsequent USQL jobs. The first thing you need to know about a U-SQL catalog is the definitions and framework and metadata for the catalog are stored in the Data Lake store. That's the primary for the Data Lake Analytics account that you first set up using that Data Lake store. Subsequent Data Lake Analytics services which use the same Data Lake store will use that same catalog that's stored in the Data Lake. By default, the first Data Lake Analytics service which connects to that Data Lake store will create the first and primary U-SQL catalog in that store and a database called master. The U-SQL catalog contains containers called databases, which are used to organize and collect the artifacts that are available in the U-SQL catalog. These include data tables, views, scripts, and code assemblies for use in U-SQL scripts. The first thing we're going to look at is the Data Explorer that comes with the Data Lake Analytics service. This shows you all of your data sources that are available on the Data Lake Analytics service. By default, you have a Data Lake Store Gen 1, which is a requirement for setting up a Data Lake Analytics service. You can add new data sources using the Add Data Source button. If you have multiple data lakes, you can read from different data lakes. If you have typical Azure's blob storage accounts set up, you can select those here as well. But the U-SQL catalog does not use a Azure storage account for its storage container. It uses the Data Lake store. As you can see, we have our standard folder set here in the Data Lake store. We also have two folders, one called System, which stores data about the USQL jobs that you run on the attached Data Lake Analytics service, and the Catalog, which actually stores all of your artifacts for the USQL Catalog. In this case, you have a database folder under that and a GUID named folder, which represents at this point the only database in this catalog, which is master. So that's the basic structure of the catalog. If you're looking at Data Explorer, you can use the Catalog tab of your Data Explorer to browse the databases and the artifacts in those databases. As you can see, we don't have any assemblies, views, tables, table value functions set up in the default master database so far. So what we're going to do is use U-SQL to create a new database and then add some artifacts to that database. For this, we'll create a new job here. Let's call this create database. Since all of these U-SQL commands are going to be running basically metadata commands. We only need to use one AU for running these. In the first instance, we're going to create a new database called Stadium. This is going to be used when we create scripts later for targeting the access data that we've got in our demo here. As you can see, create database is the command. We also have an if not exists parameter we can pass in here to say if this database doesn't exist, then create it. If it does exist, it will carry on with the rest of the script. In this case, that's the only line in the script, so that's the only one that will run. The other approach you can use to creating a database is approach of drop and then create databases. One of the benefits of doing a drop and then create is you will delete from your data lake store any of the artifacts that you have created in your database, whether that be precompiled assemblies or U-SQL scripts in the form of functions or other types, or U-SQL tables, which are pre-generated and sorted and organized data files for ease of access. Those can and will take up space in your data lake store, and you'll be charged for that extra storage. But with the drop database command, you can remove that entire database and subsequently delete that extra data, thereby lowering your cost going forward. So we'll take and submit this job now for running. After we've created the database first, be able to drop the database and then create it. If the database doesn't exist when you run the drop database command, your script will throw an error. And as we can see, this one actually took 11 seconds to prep, and once it was done prepping, it executed. And we actually didn't have any runtime for loading of data or anything like that, since this is a metadata only activity. Now, if we go back to our Data Explorer, we can look at the catalog and see we have a Stadium database here available. Of course, we don't have any tables, views, procedures, or assemblies loaded in here yet. First thing we're going to do is create a view in this database. Since last time we loaded up multiple files in our data lake store for use, we can actually reference those files in this view. A view works a lot like a view on your SQL server. In this case, you define a select statement using an extract command, which will then run over your defined data files. And instead of having to write your extract statement and declare your field list for your row set, in the future, you define your row set as select from the view. So let's go ahead and submit this. This is also a metadata command, so it should run pretty quickly here. It's the actual execution of the view by calling it in a row set select that causes the data to be read into memory. The view itself just defines the extract statement. As you can see, we've had a single blip of execution for this. Now, looking back at the create view command, you can see that it uses the pattern of drop and create with an if exists statement here. So you can drop view without the existence check, and it will return an error if the view doesn't exist. But with if exists, you can run this drop view even if it doesn't exist, and it will run without error and carry on to the next line. In this case, the create view. Create view as is the format here, and then we end this line with a semicolon. In between the view as and semicolon are the extract statement lines, which define the fields to return, field types, and the data files to read into the row sets that is returned. Now let's go back to the Data Explorer. So now that we're back in the Data Explorer, we can look in our master database, and we can see that we have a create view object in here now. The master database is the default, and of course we've created this view now in the master database, which is not where we want it to be. We actually want it to be in the Stadium database. So what we're going to do with that, go back to new job. We'll go back to our job management here. Let's take a look at the create view. Let's reuse this script. Drop view if exists. By default, we're in the master database. We actually want this script to be in the Stadium database. So we call the use database Stadium command to shift our database calls to using the Stadium. Then we'll run this command. We will actually create this view in the Stadium database. Now that script is complete. Now that we're back in the Data Explorer catalog view, if we take a look at the views in the master database, we see they're cleared out there. Now we have a view in the Stadium database. Click the query view, and you can generate a U-SQL job directly from that catalog view of the view with a name. Here we are defining a row set using a select star from a fully qualified database user view format. And you can see we didn't have to define the extractor statement, the wildcard file set. We just define a row set select, and we have an automatically generated output as well. We're going to change this, and we'll submit this job. So while this job is running, you can see that it has selected for us the files defined by the wildcard file set list. Our job graph says we've got about 1.6 gigabytes that's going to be read in here and then written out. Probably could have set this to 2 or 3 AUs for a bit faster processing. This is an instance where you were running the view and actually doing the data reads as defined in the view. This job is not simply a metadata process with actually selecting from the view like defining the view was. And now we can see our job is complete. We read 35 million rows from those 7 files, 4 gigabytes worth, and we wrote out 35 million rows, just 2.74 gigabytes worth apparently. There was overhead that was stripped out in some of the data here. We can actually see data file here. This is a tab separated value, and we've got our GUID our date time field and the other values from this. If we look at one of our inputs, we have those similar fields here. And that's the basics of using a U-SQL catalog for script reuse. In our next episode, we'll be looking at U-SQL tables within the U-SQL catalog, where we can set up data and index it for faster retrieval and reuse. Join us for that soon. Bye for now.
Click subscribe to see more videos like this. If you liked this video, hit the like button. Leave a comment in the section below to let me know what videos you'd like to see in the future.